Hi, future doctors. Welcome to the next class. So, we were discussing elongation. We will see one small problem on this. This is the area of cross section A. Its length is L. This side it is going to be 2L. So, here force 5F, 3F, here force 2F. They will give like this. So, what is the total elongation of this material or Y? Both sides same material, same area, but lengths are different. So first we will take left part, first part, second part. Left part if we are taking, this is area of cross section A, Y. So here side it is 5F, here 2F plus 3F, 5F. Why? Because total force at this point is right side, 3F force is acting, this force is also going to act here. What is the elongation formula? E is equal to FL by AY. Now what is F means here? 5F. Therefore E in first part 5F L by AY because its length is L. So if you are taking right part, so right part length is 2L Y A. Right side force is 3F. Here force 5F minus 2F. That is also 3F. Therefore total elongation E2 is going to be F is 3F, L is 2L by AY, 6FL by AY. Therefore, total elongation is E is equal to E1 plus E2. Correct? Total elongation E1 plus E2. That is going to be 5FL by AY plus 6FL by AY. 11FL by AY. So, if you want to do fastly, internal force cannot be considered, then directly also you can do 5F into L by AY, 3F into 2L by AY, like that also we can do. So remaining we will see later problems. Next concept in this, a wire, massless wire, is suspended by an object of mass capital M. Now what is the elongation of this wire, they will ask. So this is suspended at a length L, area of cross section A, Young's modulus of this wire, iron wire, copper wire, different wires will be having different Young's modulus. Now force where it is going to be applied means mg is applied at L length. Therefore, in previous problems we have applied the force. Now mg is going to apply force. Therefore, elongation formula from this, in place of F what we will write? Mg L by A by. This is the elongation formula. Now, what is the elongation of this wire? If it is taken into space, they will ask. In space, what is small g? Acceleration due to gravity is 0. Therefore, there is no gravitational force in space. Therefore, in space, elongation is going to be 0. Now, same suspended wire is taken into a lift which is moving upwards with acceleration. Then what is the elongation? If lift is moving upwards, m L by length will not change, area Young's modulus on same length they are applying. Now how g is going to be changed whenever it is moving upwards means, so we discussed in laws of motion. Upwards means g plus a. If lift is moving downwards, what is the elongation? So m, so g minus a. If lift is moving with constant velocity, so constant velocity means acceleration is 0. At the time, same mgl by ay. Where g is changing, their elongation is going to be changed. In gravitation, we discussed g is equal to gm by r square. They have taken onto a planet. On the earth, they will give like this. On a planet where mass of the planet is double, radius of the planet is half. What happens to g? Again, that g we have to substitute here. So elongation depends on mass of the planet, radius of the planet. Okay. Next, g is equal to 4 third pi rho gr. Gh is equal to g by 1 plus h by r whole square. Isn't it? So g depth is equal to g into 1 minus d by r. where G is changing, their elongation is going to be changed. This is if mass of the string is 0, means massless string. If we are taking mass of the string or mass of the suspended wire is small m, for this you have suspended one mass. Its length is L, its area of cross section A, its Young's modulus is Y. Then what is the elongation of this wire? Okay, which is having mass of the string small m, load, mass of the suspended load is capital M. Again same formula we will apply. So this wire is going to elongate according to this formula. So E is equal to mg, where this mg is going to act. mg is going to act at L length. From here to here, length is going to be L. At L length, mg is acting. Therefore, mg L by Ay. This is elongation due to this suspended load. Now, what is the elongation due to mass of the string? Means the string is having mass, where weight, total force acting because of its own weight. If you suspend this one like this, where its total weight is going to act means at center. Therefore, at center it is going to act. At center it is acting means at which length it is acting? L by 2. What is the weight? That is going to be mg. Now, because of this mg at L by 2 also, elongation will be present. Therefore, elongation due to its own mass, em is going to be small mg. And what is length? L by 2. This mg is acting at L by 2. Here this mg is acting at length L. Understood? A, y. Then total elongation when mass of the wire is suspended means when we are taking mass of the wire into consideration. So capital mg L by Ay plus mg L by 2Ay. So, like this we can write very easily. So, this is whenever mass of the string is negligible. This is when mass of the string is considered. So, we will discuss only when ideal string we will discuss. Therefore, mass of the string we will neglect. So, if mass of the string is considered means at that time this is the formula we have to use. Next, elongation due to its own weight. If mass of the wire is there, its mass of the wire is small m, where it is going to act means at L by 2. If total length is L, there is no load is suspended. So, whenever it is elongating due to its own weight is acting at L by 2 length, at center of that wire. If this is only wire you can take. So, it's because of its own weight, how much it is elongating, we are calculating. If it is having more length. Understood? So, because of own weight means elongation is going to be mg. We are going to apply this formula FL by Ay. So, force is going to be mg. Where it is acting means at L by 2 length. Therefore, L by 2 divided by Ay. So, E is going to be mgl by 2Ay. So, they won't give this mass, they will give density of the material. So, density of the material is nothing but rho is going to be mass per unit volume. Then mass per unit volume means mass of the wire is density into volume. Volume can be written as area into length. Rho AL they will substitute here. Rho AL into GL by 2AY. So, if you cancel area of cross section, rho G L square by 2Y. This is the elongation of the wire due to its own weight. Own weight means weight of the wire is going to act at center of the wire. That is nothing but own weight. There is no other load is suspended here. So that is the meaning of this elongation. So this formula you can add here also. Why? Because this is in terms of density. This is in terms of mass of the wire. Okay. So here load is not suspended. If load is suspended means this one we have to add for this. Okay. However, they are asking we can do. Next, in this another important one, breaking stress. So breaking stress is going to be, stress equation is F by A. So force means, so no load is suspended, it is going to be broken. So for what length it is going to be broken, up to where it can be safe. So that is going to be breaking stress. F is nothing but mg by A. M can be replaced, m can be replaced rho al, rho al into g by A. Then what will be cancelled? A and A. So therefore breaking stress is equal to rho gl. So what is the minimum length of the wire to not to break? By applying breaking stress they will ask what is the minimum length. Then breaking stress by rho g, very important formula. Breaking stress by rho g, or breaking stress is equal to rho gl. You have to remember this concept. Okay, so elongation whenever load is suspended we discussed. So remaining we will see in next class. Thank you.